Hello everyone. In page 40, uh, we proved sin square a equals to 1 minus cos 2a by 2. Again, each of this page uh, will be still for 80 seconds, then it will move forward to the next page. So in page 40, we proved sin square a is equal to 1 minus cos 2a by 2. So simplifying, let it be equation 1, but again, we know from previous pages that cos square a minus sin square a is cos 2a. Therefore, cos square a equals to sin square a plus cos 2a. That is our equation 2. Putting equation 1 in equation 2, we will get cos square a equal to 1 plus cos 2a by 2. So sin square a is 1 minus cos 2a by 2. Cos square a is 1 plus cos 2a by 2, which is nothing but cos square a is nothing but half of 1 plus adjacent by hypotenuse. So square of an angle, cos square of an angle equals to half plus 1 plus adjacent side by hypotenuse of a twice that angle, cos of that angle. So let's go to next page, which is page number 42. So from page 41 we have sin square a is 1 minus cos 2a by 2. Cos square a equals to 1 plus cos 2a by 2. And also we have sin square a plus cos square a is equal to 1. Now add 2 sin a on both sides of this sin square a plus cos square a. So then what you will get? Sin square a plus cos square a plus 2 sin a cos a equals 1 plus 2 sin a cos a. But sin square a plus cos square a plus 2 sin a cos a is nothing but sin a plus cos a whole square equals to and 2 sin a cos a is again nothing but sin 2a. So sin a plus cos a whole square is equal to 1 plus sin 2a. So if you substitute a by 2, we'll have sin a by 2 plus cos a by 2 whole square is equal to 1 plus sin a. So three important derivations in this page is sin square a is equal to 1 minus cos 2a by 2, cos square a is equal to 1 plus cos 2a by 2, sin a plus cos a whole square is equal to 1 plus sin 2a, or 1 plus sin a equals to sin a by 2 plus cos a by 2 whole square. So let's go to page 43. So since we have similar to what we did in page 42, sin square a plus cos square is equal to 1. Now subtract minus 2 sin a cos a on both sides. So this will lead to equation sin a minus cos a whole square equals to 1 minus sin 2a. So if you substitute a by 2, then you will have sin a by 2 minus cos a by 2 whole square is equal to 1 minus sin a. So we have sin a by 2 plus cos a by 2 whole square is equal to 1 plus sin a. Sin a by 2 minus cos a by 2 whole square equals to 1 minus sin a. Again, there is no need to memorize anything. Just it's just a different way of representing sin a's and sin a by 2's and cos a by 2's. So again, the fundamental equation is sin square a plus cos square a equals to 1. So let's go to page number 44. So let's do some problem. What is the maximum and minimum value of C1 sin a plus C2 cos a? So then always remember, whenever you have max and minimum values of a combination of sines and cosines, try to form it in such a way it is in terms of sine or cos or sine squares or cos squares, because we know the range of sine values, which is between -1 to +1, sine and cos, and sine square and cos square is between 0 and 1. So let C1 and C2 being adjacent sides of a be two sides of a right angle triangle, and C be its hypotenuse. So C1 is opposite side, C2 is adjacent side. So C is nothing but by Pythagoras theorem, and it's C is equal to under square root of C1 square plus C2 square. So C1 is nothing but C sin B, C2 is C cos B. Substituting C1 and C2 in the original equation C1 sin A plus C2 cos A, we will see that it is nothing but C of cos A minus B. But we know cos angle is between -1 to +1. So multiply C on both the sides of the equations, or on all the sides of the equation, then it is minus C less than or equal to C of cos angle, which is cos of A minus B less than or equal to C. So minimum is minus C, but we know C is nothing but underscore C1 plus C1 square plus C2 square. That is so the minimum is minus square root of C1 square plus C2 square, and maximum is nothing but C, which is under root of square root of c1 square plus c2 square. So the max and minimum value of c1 sin a plus c2 cos a is nothing but minimum is minus under minimum is minus square root of c1 square plus c2 square. Max is square root of c1 square plus c2 square. So just remember that one. Now let's go to page 45. Now similarly we could have considered the same thing in a different way. If we swap the c1 and c2 places, like before c1 was opposite side, c2 adjacent, now c2 is opposite side and c1 is adjacent, and again still c is a square root of c1 square plus c2 square, and if you substitute c2 and c1 in terms of sine and cosines, then the equation can be minimized to c of sine a plus d. It should be a plus b, sorry, or a plus d. Yeah, it's correct. C of sine of a plus d. So, but again we know sine of a plus d is between minus 1 to 1. So it is obviously the minimum value is minus c, maximum value is plus c. So again we come to the same conclusion. The minimum value is minus c, that is minus square root of c1 square plus c2 square, and that is the minimum value, sorry, and the maximum value is plus c, which is square root of c1 square plus c2 square. Let's go to page 46. So in a similar tone, what is the max and minimum value of c1 sin a minus c2 cos a? Let's follow the same procedure. So consider right angle triangle with the opposite side as c2, adjacent side c1. We could have done another way. We could have considered opposite side as c1 and adjacent side c2. So hypotenuse c is square root of c1 square plus c2 square. Now c2 is nothing but c sin p, and c1 is nothing but c cos p. And now substituting c2 and c1 in the original equation, c1 sin a minus c2 cos a, it can be minimized to equation c of sine of a minus b. So sine of a minus b, which is nothing but a sine angle which lies between minus 1 to 1. So c of sine of a minus b is between minus c and plus c. Therefore minimum value is minus c, which is minus underscore c1 square plus c2 square, that is minus square root of c1 square plus c2 square, and minimum is that's the minimum, and the maximum is plus c, which is square root of c1 square plus c2 square. Same thing will hold true for same as c1. This is the same minimum and maximum for c1 of sin a plus c2 of cos a. So any combination of the sine and cos, the addition of sine and cos, c1 sin a plus c2 cos a, or c1 sin a minus c2 cos a, we have the same minimum and maximum value. Let's go to page number 47. So let's do another calculation. What is the max and minimum value of 4 sin a plus 5 cos a? So based on previous derivations, we know that minimum value is minus c, which is minus square root of c1 square plus c2 square, and max is square root of c1 square plus c2 square. So we know c1 as 4, c2 as 5. We have the values. Max as under square root of 41. It's under root of 41, square root of 41. Minimum is minus square root of 41. Now let's do a different kind of a problem where we want to find out minimum and maximum value of sin a per cos a. Now let's consider, we know sin 2a is, but again whenever we have a question in terms of sines and cos and asking to find minimum and maximum, always minimize that sines and cos into such a way that you end up either with squares of sines or cos, or squares of cos or squares of sine, or just sine or cos, because we know the range of sines and sine squares or cos squares. So since the question is about sin a cos a, we know sin 2a is to sin a cos a. So sin a cos a is nothing but sin 2a by 2. But again, sine of angle is between minus 1 to 1. So sine of angle divided by 2 is nothing but between minus half to plus half. So minimum value is minus half, maximum value is plus half. Let's go to page number 48. So what is the minimum and maximum value of sine square a and cos square a? So this is really good. In a previous equation we proved sine a and cos a is between minus half to plus half. So when you square it, then we have only positive value. Therefore mod of sine a cos a is less than or equal to half, squaring on both sides is nothing but sine square a cos square a is less than or equal to 1 by 4. But again, we know sine can be 0 and cos can be 1 at the same time, so then the minimum value should be 0, because it's a sine square and cos square is always positive, there is no negative number, and the upper limit is 1 by 4, that is they are less than 1 by 4, so the lower limit should be 0. So so minimum value is 0 and maximum value is 4, because if you put a is equal to 0, there's sine a is 0, cos a is 1, so still the product is 0, so minimum is 0. Let's go to page number 49. So what is the minimum and maximum value of sine square a plus cos power 4a? This is very tricky question, so let's see. Y is equal to sine square a plus cos power 4. Let y is equal to sine square a plus cos power 4a. Now we can add and subtract cos square a so again, if you look into the line joining, sine square a plus cos square a is 1 plus cos power 4a minus cos square a. If you take cos square a common there, 1 plus cos square a and times cos square a minus 1. If you rearrange the terms, if you take the negative minus 1 outside, it will be 1 minus cos square a into 1 minus cos square a. But we know cos square a is 1 plus cos 2a by 2. So the equation is now 1 minus cos square a times 1 minus, it should not be equal, but it should be multiplied, 1 minus cos 2a by 2. So if you look into the back of the equation, I think I'm sorry, cos square a is 1 plus cos 2a by 2, so 1 minus cos square a is nothing but 1 minus 1 plus cos 2a by 2. If you subtract it, it will be 1 minus cos 2a by 2. So that equation is right, in fact. Now substitute this cos square a value, which is 1 minus cos 2a by 2, into the original equation, that is 1 minus cos square a times 1 minus cos square a. So 1 minus cos square a is cos square a is nothing but 1 minus cos 2 by 2, and 1 minus cos square a is nothing but, so cos square a is nothing but 1 plus cos 2 by 2, 1 minus cos square a is nothing but 1 minus cos 2 by 2. Substituting both of them in the original equation, we have 1 minus cos 2 by 2 multiplied by 1 plus cos 2 by 2. So doing some calculation, we end up with the results. It is 3/4 plus cos square 2a by 4. Now cos square of angle is between 0 and 1. Cos is between minus 1 to 1, minimum and max. Cos square, which is always positive, is between 0 and 1. So when a is 0, or sorry, when a is 0, which is like a maximum value, cos square of 0 is 1, so we have maximum value of 1. But when cos square of 2a